Hello everybody, welcome to the second video on the Extract API. In the first video, we downloaded and installed Python and the Python module for the Extract API. So if you haven't done those things, please go back and watch the first video. The purpose of this specific video is to create more of a real-world example than the script we built in the first video. We'll be connecting to real data, in this case in the form of a CSV file, and spitting out a TDE using Python. Besides having Python and the Extract API module installed, you'll also need to have these files, which if you didn't download from the first video, you can download from this webpage. They should have these three files. The trivial example finished is the one we created in the first video. CSV to TDE is the finished example of what we'll create today, so you can use that if you get lost along the way in today's video. And the Superstore CSV is what we'll actually be reading from to convert to a Tableau data extract. Okay, let's go ahead and get started. Just as we did in our first video, we'll be using the application idle to create our script. So if you have Python installed, you should be able to open the Start menu, type idle, and open that application. To create a new script, you'll need to go to File, New, or Control-N, and then File, Save As. We'll call this our CSV to TDE.py. Now be sure to save this in the same directory where Superstore CSV lives. Okay, we created our new file, now we're ready to get started. The first thing you do in almost every Python script is to import the modules that you'll need to use. In this case, of course, we need the Extract API module, data extract, and I like to give it an alias as TDE. We'll be doing manipulation of files again, so we'll need to import the OS module. And one of our data types is a date time. So this module helps you manipulate those. Finally, because we are connecting to a CSV, we need to import the module called CSV, which will aid us in reading from the CSV file. This CSV module is included in Python's library, but very often is the case that you'll be connecting to a data source that does not have a built-in module. For example, if I were connecting to Microsoft SQL Server, there's no built-in module for that, so it would just be a matter of opening up my browser and searching for something like Python module SQL Server. And here is a Python module called PyMS SQL, which will allow you to read from SQL Server. What if you were reading from something like MongoDB? There is a module called PyMongo. So pretty much any data source out there is going to have some module probably created by the Python community that will aid you in reading from it. In this case, once again, we don't need to do that because the CSV module is already included. Okay, we've imported all of the required modules. Now we'll get started in actually connecting the data and creating our extract. I'll follow pretty similar steps to the first video. Step 1 is to actually create the extract. And also as part of the first step, we'll just go ahead and get the CSV ready and open it up. Now in the first video, what we did is we wanted to simulate a full refresh. The way we did that is if the extract already existed, we'd simply delete it and start from scratch. However, you can also treat your Extract API scripts as an incremental refresh. So I already have an extract. I want to add rows to it. And the way you do that is you simply open the existing extract and then insert rows just as we did normally. Those will be appended to the bottom of the extract. So because we don't need to delete the file if it already exists, we'll just go ahead and open it, whether it exists or not. If it doesn't exist, it'll be created for us, and if it does exist, it'll just be opened. So tde.extract, data_extract.extract will create a new extract file for us, or open the existing one. We also need an object for us to read from the CSV. So we'll call that CSV module.reader. Specifically, we want to open the CSV, and we need to pass in the name of the CSV, which in this case is superstore CSV.csv. These are all case sensitive, so make sure you get all of the capitalization correct. And what we're going to be doing to this is reading from this CSV. So we need to tell it what kind of mode we're opening in, and that's RB mode, which is just to read from. There's optional arguments here, delimiter. And just to be safe, we'll be sure to specify explicitly the delimiters. In case that's hard to see, that is a single quote, then inside a double quote, and then closed with a single quote. Okay. Now earlier what we did is we then went ahead and created the table inside the extract. However, what we need to do in this case is check if the extract already exists. That is, if it already has a table. And in that case, we can skip the part of the script where we define the table definition and add the table. So essentially what we'll do is we'll check, does the TDE file that we just opened or created have a table? If this extract already exists, then this will return true, in which case we don't need to define the table definition. We can simply grab the table with TDE file.open table extract. We'll also be able to grab the table definition, which we'll need to define new rows, with table.getTable definition. And as always, these are all case sensitive. If this returns false, if tde.hasTable returns false, then essentially this is a new extract, and we need to both define the table definition, all of the metadata inside, and create the new table. And that is step 2 from the previous video, create the table definition. Now, to start with, we'll create essentially a blank table definition with tde.table definition, open parentheses, close parentheses. One thing to note before I get too far past this is, as always, Python has significant white space. That means this needs to be a tab, and this needs to be unindented. So if, then you have a colon, everything indented under the if falls under the if, then we create an else, and everything indented under the else will be evaluated if the TDE file that has table returns false. So now we just need to go through one by one each of our columns and define what's the name of that column and what data type it is. The first column we'll create is called row ID. And the type of it is tde.type.charString. This line is actually repeated from the previous video. The next column is order date. And the type of it is date. Next is sales, which is a double. And so is profit. Next we have our customer name. Then we have our zip code, which is an integer. And lastly, we'll include the product category, which also, of course, is a char string. Now, in this specific script, we know exactly what columns are in there, and we're manually inserting them. So we know what they are, and we know what file type, data types they are. Often would be the case that you want to do this part dynamically. That is, you don't know when you're writing the script which columns are going to be in there or data types. And there's a variety of ways to do that dynamically. One would be to do some detection of the data type. The other would be to read a schema.ini for CSVs and XLSs, which will define essentially is a schema for the file, and you could read from that, loop through it, and define the columns based on that. If you look in the documentation for the extract API, which is in the zip file when you download the extract API, there is an example of a CSV to TDE where we don't define the columns manually as you see here, but instead we define them by reading through the schema.ini and looping through and adding the columns. The third step after we define the table def is to create a table in the image of the table def and store it in a variable called table. And as always, with the extract API, the first argument to add table is just the word extract. And then the second argument is the table definition variable that we just filled out up above. Now note that if TDE file.hasTable had returned true, that is, if the extract already existed, we would have skipped all of that stuff and we would have already had our table and table definition without having to define them as we did in steps 2 and 3. Okay, we have everything defined. Step 4, whether the extract exists and we're appending to it or whether it's new, either way, is to loop through the CSV, grab all of the data, put it into rows, and insert those rows into the table variable. So the first thing to do that step is to create this new row variable. We'll be using this over and over through each iteration of our loop. And we create essentially a blank row, but it serves as a skeleton for a row defined by the table definition. So we pass in the table def into the argument of that row creator. Now the way we'll read through this CSV and grab the data we need is through this CSV reader object. Now the only thing we need to do to prepare that is go to the second row, because the first row in this CSV is the headers. We don't want to include those when we read them, when we read the CSV. Now we're ready to start looping through the CSV reader and adding the data to our extract. So we'll loop through each line in the CSV reader and grab all of the data. Now the way we grab all of the data the way we put all of the data into our Tableau data extract is first by putting it into this new row object with new row.set and then the name of the data type we're adding. So the 0th column is a char string, so we need to call new row.set char string. The first argument is the index of the column. So this is the 0th, so we pass 0. And we want this to be a string, so we'll be sure to cast it to a string. And what we want to actually pass in is a string representation of the 0th column from the CSV. So line is our current line in the CSV. We grab the 0th column, which we happen to know is row ID, and then we insert it into the 0th column of this new row variable. Then we'll repeat the same step for each of the other 6 columns. Now the next column, the first column, is type date. And we have to do a little bit of extra work to get this from a timestamp, a date stamp, 12/31/1982 or whatever, and put that into a Python date object so that we can then put that into the new row object. So we imported this module datetime, and that has an object called datetime, which allows us to call this function stripTime. And that's a way to kind of parse the date date stamp into the correct version. So what date stamp do we want to grab? That's the first column of the current line in the CSV. And then stripTime allows you to specify the format, which looks like this. So two-digit month and a 2-digit day and then a 4-digit year. So grab that. stripTime will then return a Python date object and put it into this variable called date. And what will we do with that date object? We'll insert it into our TDE with new row.setDate. First argument is the column index, which is 1. And the way you do setDate is by specifying the year, the month, and the day. If you were doing setDateTime, then you would need 2 more arguments. In this case, we just need the year, which is from this date object, date.year, date.month, and date.day. The rest of the columns are a little more straightforward. We just grab them from the CSV and put them into the TDE. So the next one is the sales, which is a double. So we'll do a new row dot set double 2. We want to cast this to a floating point. Line sub 2, the second column of the current line. The next column is profit, which is also a double. So I'll just copy, paste, new row dot set double, and I'll change both of these 2's to 3's. The next column is our customer name, which is a string. So that is table def, new row dot set char string, column number 4. And no casting needed because CSV reader will just read this as a string. Next is our zip code. Which is an integer. In this case, we will cast what CSV readers to an integer just in case it reads it as a string, or if it's stored as a string. And the last one is another string product category. So we've created our new row variable. We defined it by the table definition, and then we inserted the actual data into each of those columns. So that new row now is ready to be inserted into the extract, specifically into the table. So table.insert, insert that new row. So this will loop through one line in a row, one line at a time, and grab all of the data from the CSV, insert it into the TDE. That's all we need to do in the loop. So this, at the end, after this loop is done executing, the table should be ready to go. Once again, always be sure to unindent when you're done with your loops. And then the last step is a simple one, but it's an important one. Close the TDE. And you'll notice that Python or idle by default had me indented. Just make sure that you're unindented, otherwise it'll try to close the TDE file in every iteration of the loop. Okay, so I'll go ahead and save that. Then I'll navigate to it in my file system. Here it is, CSV to TDE. Just make sure it's there. But the easiest way to run it is to, in idle, go to run module. If it executed correctly, I shouldn't see any errors or anything like that. Then I can go back to my file system, see that the Superstore CSV extract is there. Now I can double click on it, open it up in Tableau. We can see that it looks like the data is correct, and then I can open it up and start to do some analysis. Now, just to show the idea that if we ran this script again, it wouldn't create it from scratch, I'll put on labels here and just keep these numbers in mind: 5.1 million, 3.7 million, 5.9 million. Now I'll come back to idle, and I'll hit run module. It'll go ahead and run through that again. And now if I open up Superstore CSV Extract, we can go back to Tableau, bring in our product categories again, put on labels, and as you can see, they're all double because what we did is we just read the data again. Of course, in real life, you wouldn't just duplicate the data, but what you might do is have some logic where you're only grabbing new data, or maybe grabbing this month's data that happens to live in its own CSV, and only putting in those new rows of data into the extract. So that's pretty much it. Hopefully this example taught you how to create more of a real-life example of using the Extract API. Actually connecting to data, whether it's using the built-in CSV module or whatever module you're able to find on the internet to fit the needs of your data source. Then creating the table definition either manually or dynamically. And finally, adding the data as you read from it into the Tableau data extract. Also, I hope you understand how it works if you want to insert rows instead of just deleting the extract and starting from scratch. But that's it from this video. I hope you've learned a little bit about the Extract API. Have a good day. Bye.